Welcome to the Explainer. Today we're diving into something that is, quite honestly, a massive game changer. We're looking at a genuinely groundbreaking 2026 paper by Brett Goodwin titled Spectral Persona Modulation, Eradicating Autoregressive Myopia via Active Inference in Semantic Manifolds. What we're unpacking today fundamentally rewrites how artificial intelligence actually constructs a thought. We are moving entirely away from the AI we know today and exploring a completely new linguistic architecture. Here is our roadmap to unpack all of this. First, we'll cover the autoregressive myopia problem. Then, looking at language as a wave. Next, spectral persona modulation, followed by active inference decoding, and we'll wrap up with running on the edge. All right, Section 1, the autoregressive myopia problem. Let's get right into the fundamental flaw that is currently holding back modern conversational AI. Right now, your standard large language models suffer from what this paper so brilliantly calls autoregressive myopia. Basically, they are practically blind. They operate by probabilistically guessing the very next word or token just based on a localized context window. And they do this without mathematically anticipating how the sentence is actually going to end. Because they completely lack this global semantic planning, they're forced to just sort of constantly adjust their trajectory on the fly. This is exactly what leads to those frustrating conversational dead ends, the wild hallucinations, and those robotic stuttering cadences we've all come to recognize. The contrast here is just staggering. On one hand, you've got current token-by-token prediction models, which are basically stepping blindly forward on isolated blocks, just crossing their fingers that the sentence makes sense at the end. But on the other hand, we have the FSGSGR framework. That stands for Frequency-Governed Self-Graph Reasoning. This new framework generates a completely finished, continuous semantic thought before a single word is ever spoken. Moving on to Section 2, language as a wave. Because to actually fix this myopia, we have to completely change our underlying definition of language itself. We really have to stop viewing text as a sequence of isolated, discrete, categorical variables. As Goodwin's paper points out, this new architecture actually treats a linguistic sequence as a continuous spatiotemporal wave. So an encoding function takes a discrete sequence of tokens and projects it into this incredibly dense, continuous time semantic manifold. It's kind of like taking a chunky, pixelated 8-bit image and upgrading it into a perfectly smooth, infinitely scalable vector graphic. The sentence isn't just blocks of words anymore. It's a continuous 1D wave that maps the exact fluctuation of specific concepts over a narrative trajectory. Which brings us to Section 3, Spectral Persona Modulation. And the absolute easiest way to understand how we control this continuous wave is to picture a highly advanced mathematical audio equalizer. This equalizer process happens in 4 distinct steps. First up, the semantic Fourier transformation runs the thought through a 1D discrete Fourier transform. This mathematically separates the rigid facts, the structural geometry, from the stylistic energy. Next, target bandpass filtering isolates the mid-frequencies. Third, magnitude modulation injects the specific emotion right into those isolated frequencies. And finally, inverse projection reconstructs that modulated frequency tensor back into a complete, watermarked continuous thought. And here is exactly how that mathematical separation plays out. The AI strictly preserves the low-frequency band, which we call the anchor. This holds the core narrative, the temporal facts, basically the logical ground truth. The AI is mathematically bound to this anchor, meaning there is zero chance it hallucinates the facts. Then you have the mid-frequency band, or the flex, which holds the stylistic and emotional energy, so the vocabulary and syntax. The system applies a persona frequency mask entirely within this flex zone to alter how the facts are delivered without ever touching the facts themselves. So by isolating these mid-frequencies with a radio bandpass filter, the AI can geometrically inject specific emotional topologies directly into the spectral magnitude. For example, an empathetic persona is mapped out as these smooth, low-variance transitions in the latent space, whereas an urgent persona introduces high-variance, rhythmic spikes. It perfectly balances the factual narrative with the exact emotional cadence you want. All right, Section 4, active inference decoding. Because once this perfect, continuous, emotionally modulated wave is built, the AI has a brand new problem, translating it all back into discrete, readable words. See, in standard token-by-token generation, turning a continuous state into a discrete word introduces quantization error. If a model is forced to make even a slightly suboptimal token choice, that error compounds rapidly, and that leads to catastrophic grammatical failures further down the line. But this framework, it uses an active inference decoding schema. It treats that perfect continuous wave as the ultimate target. So instead of guessing word by word, it minimizes variational free energy by evaluating the entire sequence simultaneously against that target. This completely bypasses those compounding quantization errors. What the sequence-level minimization achieves is honestly a kind of magic. It creates bidirectional balancing. Think of it like a semantic budget. Because the AI evaluates the sentence globally, it organically resolves the tension between the factual anchor and the emotional flex. So, if the AI spends its creative flexibility on a slightly imperfect synonym early in a sentence just to sound, say, more empathetic, it mathematically borrows that semantic weight and naturally rebalances the grammar and syntax later in that very same sentence. So, the crucial takeaway here is that instead of rolling probabilistic dice to guess the next word, the generative agent is essentially solving a geographic puzzle. It maps out an entire syntactic trajectory across the discrete vocabulary space and finds the exact one that minimizes the L2 norm geometric distance to the target continuous state. It's not guessing at all, it's geographically aligning. Which brings us to Section 5, running on the edge. The math works perfectly, yes, but it introduces a massive practical hurdle. Because calculating every possible vocabulary combination across a whole sentence to find that perfect L2 distance, that is an NP hard search problem. A brute force evaluation of all those possible trajectories would just completely stall inference. Put simply, trying to evaluate the entire vocabulary space globally like that would instantly melt the memory of smaller, decentralized edge computing devices, like the NVIDIA Jetson or Nano architecture. To solve this, the authors introduce what they call continuous relaxation beam search. Rather than evaluating the whole space, this algorithm projects the continuous vector onto the vocabulary manifold to establish a very narrow heuristic corridor. It only evaluates the top geometric paths and strictly prunes any mathematically distant vocabulary trajectories super early on. This preserves all the magic of that bidirectional balancing while strictly bounding GPU memory allocation, meaning it is actually deployable on highly constrained edge hardware. The implications of this framework are just monumental. By treating language as a frequency-governed wave decoded via active inference, we are finally eradicating autoregressive myopia. We now have an architecture that achieves true global semantic planning, an AI that actually thinks before it speaks, balances its syntax bidirectionally, flawlessly separates emotional tone from unshakable factual ground truth, and can compute all of this in real time on multi-agent edge swarms. So, I'm going to leave you to ponder this final, genuinely fascinating question. If an artificial agent can meticulously, mathematically engineer a flawless, empathetic response, literally borrowing and spending semantic weight to sound perfectly human while rigidly holding on to a factual core, how will we ever distinguish synthetic empathy from the real thing? Thank you so much for joining me for this explainer on what is truly an incredible leap forward in generative architecture.